So now you're world experts on the physics of heat. Let's see how we can apply what we've learned in order to measure the heat of reactions. Now, the first thing to get into your heads is that the reaction is always going to be the system. Okay, so the reaction has a heat change, right? Q of the reaction, that of course when we put it in terms of moles becomes delta H. Trouble is though, we can't measure the heat change of a reaction because it's all the atoms and molecules banging around, breaking bonds and making bonds and doing their things. We can't just stick a thermometer in to a molecule's whatever and measure its temperature change. We also can't talk about the specific heat of a reaction or the heat capacity of a reaction. So we can't measure the heat of a reaction. We can't measure Q of the system. But of course we don't need to, because if we can measure Q of the surroundings, well then Q of the system, the heat of the reaction, is minus the Q of the surroundings. So in a calorimeter, what we always got is we got a reaction going on that is doing something to the surroundings. Now we're going to think about two types of reactions. First of all, we're going to think about reactions that take place in solution. Okay. Now in order to do that, usually we just use a simple coffee cup that's filled with water and that has a thermometer in it. Okay. And the idea is that our reaction, which is going to be taking place in that water there, so you can't actually see those reacting molecules, but they're going on in the water, that is going to give out heat or take in heat. It's going to give it out or take it in from the water. So we measure the temperature change of the water. We also presumably know the heat capacity of the coffee cup, so we know how that temperature change has affected the coffee cup. Work out Q of the surroundings, and just like we did in that last calculation in the last movie, and then we can get Q of the reaction. Now, things you can do to make this better. The first is you have the calorimeter, as we call it, otherwise known as a coffee cup in most cases, as insulated as possible. So a lot of times you'll use 2 coffee cups. Okay, and then you also want a lid on it so that you're having as little heat escaping out into the air as possible. Okay, and then if you want to be really good, you fill the coffee cup up as much as you can, so you don't have to worry about the difference between the water and the air that's in your coffee cup. But anyway, reactions in solution we just do simply in a coffee cup. However, an awful lot of calorimetry is associated with combustion reactions, a burning of something, and we obviously can't just put something in water and burn it, so we have to be a little bit smarter. Now at A level, what you typically do is you use this little setup here using a spirit lamp. You again have water with a thermometer and a lid, so this is going to be the surroundings, right? The water in the calorimeter for which you measure the temperature change, but then instead of doing the reaction inside the water, you just burn something outside the water. So you have a combusting liquid in a little container here that has a wick that you set light to. So you burn using the fuel of your combusting liquid, and that heats up this calorimeter here. Now obviously at this point you probably don't want to use a polystyrene coffee cup, although some people do, but you do need some kind of insulated container to heat. And of course you want to get the flame as close as possible to the bottom of your calorimeter so that you're not losing heat going out all the sides and so forth. So that's the A level experiment to do a combustion reaction. You do the combustion here effectively, and you hope that all the heat produced by the combustion, that's the system, goes into increasing the temperature of your surroundings, the water and the calorimeter. When you do this as a professional thermodynamicist or calorimetry person, you use what's called a bomb calorimeter. Now, a bomb calorimeter is where again you have a calorimeter that is filled with water, okay, and you have your thermometer in there. So you're going to be doing the reaction in a way that's going to increase the temperature of the water, and of course as that's increased, it also increases the temperature of the calorimeter around it. So you need to know the specific heat of the water inside, how much water you got inside, and you need to know the heat capacity of the calorimeter. However, inside this water is a little compartment, right, that's part of the calorimeter that is called a bomb. Okay, and you put the combustible in there, so it could be a liquid, it could be a gas, you're putting in there what you're going to burn, and then you have a little way to ignite it, just an electrical ignition point. So you fill what's in here with your combustible substance, you close everything off, you ignite it, that combustible substance combusts, gives off heat, he warms up the calorimeter that includes the bomb and the water inside the calorimeter. So 3 different calorimeters there. Simple coffee cup for doing solutions in water, the spirit lamp where you do a combustion outside and heat up the water from the outside, and then the bomb calorimeter where you do effectively the combustion inside the water and heat up the water that way.